Well, since it's 5 minutes past, I think we can already start. So I thought I'll just bring up the slides, and they have a really good summary. So we can just have a quick run through the summary, and then we can discuss any questions you have, and then afterwards we can see if there's any issues with collab 0, which hopefully everyone found fairly straightforward. Can people see my screen?
Yep.
Yep. So kind of like their first lecture is fairly it's more kind of like a very introduction type kind of lecture. So it's more kind of talking about what the course is going to cover. So so kind of one of the main things that they brought up is that there's a different kinds of ML tasks that you can do on graphs, and they kind of follow these kind of different types of tasks. So for example, like there's node classification, which is like a property, which are what are the properties of node. Like for example, if you consider everybody in a social network as a node, like what kind of user you are, and then there's like the link prediction tasks, and which is like they're kind of like predicting like whether there should be links between two nodes. And knowledge graph completion is kind of one of the big tasks, and it's actually a fairly big topic of research. And then there's a graph classification, which is like if I have a graph that looks like this, what would it do? For example, like molecular property prediction. And then there's clustering tasks, which is if nodes form kind of like is this going to be like a group of people sort of thing. And then they also mentioned graph generation for drug discovery and graph evolution, which is quite interesting because they're showing the physics simulation thing, which they model with their graph neural nets. Yeah, and then so they gave very examples of different kind of like prediction tasks, which I guess hopefully you'll have had a chance to go through. Yeah, and then so kind of the harder part is for this week is for like the ML traditional ML discussion on graphs. So they kind of again, so the tradition is traditional in the sense that is talking about how do you generate features for different kind of graphs and nodes, and how you can use these features as input to like quote unquote traditional ML models like random forest, SVMs, and so on. So I think let me bring up yeah, so again, this is they kind of like divided into node level features, link level features, and graph level features, and they have a fairly decent summary at the end of each section, which I just need to find. Yeah, so they have for node level features, again, there are like, so they kind of divide it into important base features like node degree, centrality measures, and then this once they're about structure of a graph, like for example, again, like the node degree, the clustering coefficient of each node, and kind of like the graphic count factor. And so kind of again, so and then they go into a little bit more detail in the summary about what the different kinds are. So for example, the important base features is that like whether your node, if it's really connected to other, if it has a high degree, then it has got a lot of links to other stuff, which might indicate that you're more important, or the centrality, which is actually a more robust way of measuring the importance of each node, and they kind of, an example is that like who are the influential people in a node. And then the structure-based features are basically more about the properties of a graph around a node, for example, like how connected your neighbors are. And also they introduced the concept of graphlet, which is a bit like different patterns that occur in a graph and around a node. So you can, if you can kind of think of graphlet degree vector as like a bag of words for graphs. And yeah. And then so they then go into the link prediction tasks and features, which is kind of, so there's two different link prediction tasks, which is that are there missing links in the graph that we should have known about? Like, for example, if you think of Wikipedia, then not every, there might be like certain references that are not linked properly. And if you map Wikipedia into a knowledge graph, then there might be actually extra links that you should be adding to the graph. And then the other kind of link level prediction task is that like what happens over time. So if kind of like if these like certain nodes might not be connected at time at the current time, but they might be connected in the future. And the idea is that can you predict these connections in the future? And so kind of, again, let's go to the summary. So there's like different features they can generate from the links, and kind of they're related to kind of the two nodes at each end of the kind of like both the edge feature and the node, kind of like what two nodes connected. Sorry, listening.
I have a question. Back on just a couple slides before that, on slide 37, on the third bullet point, could you articulate that formula, how that's working? I get what's happening, and I get the intuition, but for some reason I'm having a hard time reading that particular expression.
Yep. So let me remind me. So, oh yes, yeah. So it's kind of like discounting the number of paths between two nodes, and so the P, U, V, K thing is basically the number of paths of length K between the two nodes. Or so so here, like, so kind of like if you want the two nodes as 1 and 3, then the number of paths of length 2 between these two is there's 1, and there's like, and path of length 1 is 0, and path of length 2 is also no, 3 is also 0. And then kind of if you start from, let's say it's 1 and 2, then you have one path of length 1 and one path of length 2, and etc. And then so this is so this is if I want to count the number of path of length 2 between U and V. And then you kind of, so kind of, and then you kind of like you count how, and then you kind of like you for the neighbor of U and V, then you count like, so how many, so basically because you need one hop from U to a neighbor and then one hop from the neighbor to V, then you count how many the number of paths of length 1 between U and U's neighbors and V neighbors, and then you kind of and then from those neighbors to V, and then it multiplies, I'm not sure if I made it any clearer or not.
Well, no, I get what's happening, and I understand the intuitions, but I guess where I was wondering on that first summation symbol, the subscript I, what is that a designator for? And then again, you see, then the adjacency matrix UI, and so I was multiplied by the powers matrix for a single hop IV. And I was like, well, what's the IV? I was like, I'm a little thrown off by the I. And just this expression, that's all. I was just
Oh, so that's the intermediate node. So that's the big the neighbor that's shared by U and V. So you hop so go from U to I and I to V.
I got it. Duh. Okay, thank you. That clarifies it. Thank you.
Okay, cool. Yeah, so going back to the summary, so the link level features is there's like distance-based ones, which is fairly easy. It's just like the shortest path between the two nodes. The caveat being that it doesn't really show you what the neighborhood is like, and then the local neighborhood overlap, which is like how many neighbors are shared by two nodes. But again, if your graph evolve over time, it kind of like if the two nodes are not currently sharing a neighbor, but if they are very likely to share a neighbor in the future, this doesn't capture it. And then the global neighborhood overlap feature, which uses the whole graph structure to score the two nodes. So for example, like the CAS index, which we were talking about earlier, which is the paths of all different lengths between every every node pair in the graph. And then the last kind of features is the graph level features and graph kernels, which is useful for like kind of like as the previous slide has said, I mean like a few slides back, where they're saying that it's like for predicting like the whole properties of whole graphs like a molecule. And there's two main kinds. So they have the two main kinds of features, which is like the graphic kernel, which is they basically break down a graph into all this kind of different patterns of graph motifs, and you kind of count how many of them there are of each one. So it's like a bank of graphlets sort of thing. But obviously, the way that you have to kind of loop to all the possible combinations, and it's really expensive. And then
if I can interject before you you move on to the Weisweiler in the graphlet kernel, in terms of the computational expensive portion of it, when it talks about the exponential increase of the summation, did you I get it, but it's just not resonating with me. My understanding of that. Could you did that? Maybe you can articulate it better than what I understood from the instructor about just the exponential portion. Why it was exponential. That's the slide. Yes, the NP.
So I think it's because
if you look back at the graph when he's explaining what graphlets are, and then he shows kind of a bunch of different graphlets as you go from like 1 node to 2 nodes to 3 nodes to 4 nodes. By the time you're looking at pass of 4 and the graphlets that include that,
I got you.
It's because those grow so quickly.
Yeah, I got
so
you.
You end up having to search as it gets larger and larger, the graphs, and you're trying to find all the different connections. Those continue to grow and grow and grow. So searching that space, starting from 1 all the way up to 4, even at 4, it's like up to 76 or something like that. Possible
72,
combinations.
Yeah, I get you. Okay, that makes sense to me now. I thank you for making that more apparent. Thank you.
Yeah, so and then the next idea is to something layman term I can pronounce the first word. And it's basically they call it color refinement, which is it's more like the colors, you can think of it as like different numbers. And you basically apply it recursive. So kind of like you apply it for a fixed number of steps, and like the kind of like the number representation is basically summing up of all your neighbors' features. And so the graph is you kind of like count how many nodes of each color or number there is, and it's actually the graph neural networks actually have a very similar idea of like this message passing propagation thing. Yeah, and then so this is
I thought that was really interesting, that what you just described, how they came up with that. I thought that was fascinating.
Yeah, it's
Agreed.
It's like this one.
Just to the novice, that's when you just look at that for the first time, it's like, oh man, that's brilliant. Yeah, it's probably old news to many people who may have looked at this before, but to me, it's like, wow, that's powerful, I think.
Yeah, definitely. Yeah, because like if you have looked at the later lectures, it's like one of the core concepts of like graph neural nets is this kind of message passing thing where you kind of sum up all your nodes, your neighbors' features, and do some sort of operation on them. Yeah, so it's actually a really cool idea.
One thing he didn't really explain was what hashing algorithm would be ideal, and also when to stop. Because this process, you could just keep going realistically. Is there like a number when you'd want to stop doing this? Because it is, you repeat the same process over and over. There isn't like a stopping condition that was defined.
Yeah, I think it wasn't explained, but what I think is that there could be two ways to deal with it. I mean, not two ways it could be going. I haven't checked it yet. One is it's some sort of a hyperparameters, I mean, number of iterations you go through, or another thing could be that after a while they get stabilized and I mean, they stop changing, something like that. I'm not sure. I should plan to check it, but
yeah, maybe I missed it. I have to go back and take a look. But I was like, when do we stop? We can just keep repeating this.
My feel from what he said was that that's a number, a parameter that you choose when you stop. Just the way he talked about it in slide 59, about the one that he had went over. That was my feel, but I don't have a explicit point at which he said this is when you stop. Like you're wondering.
Yeah.
I think, well, I mean, I didn't look it up either, but usually these things are, you kind of, because I'm wondering if it's a bit like, for example, k-means, where you kind of try different value for k, and where it sort of plateaus off, you kind of pick the value at the king.
Yeah.
It's something like that, or maybe like as Fika said, it's like when it stops changing very much. Which
yeah,
in a way
if the groups stop changing, maybe like if you say, if you assume that the 6 remains 6 after 3-4 iterations, then you stop. Then you stop it, some kind of that condition. So I still have to look into it and see if anyone has any other idea. Maybe somewhere it has different, but yeah, I think that could be one of the things.
Yeah.
anyone else
if we can also like share some relevant material to this, would be like great. I mean, if you don't have the answers, we can also look into it and then come back.
Anyone else has some thoughts or questions about this week's stuff?
How did everyone feel about the time commitment?
I mean, I found it quite doable, but it's also the first week with like one lecture that's mostly introduction. So I don't know about what other people feel.
I thought it was doable, but I made the mistake of misunderstanding what we were doing this week. I just assumed everything we were doing was just in the 1.2, 1.1, 1.2, 1.3 area. And I didn't realize it was also 2.1, 2.2, 2.3. So I had to scramble early this morning to catch up with that. And it made me think about folks. So for me, that was, if I had known that, that wouldn't have been a problem all week, but it made me think about folks who, might be working full time or something like that, that maybe it'll be really hard for them.
I kind of thought, at least this week we had like, what, 1 and 2? I thought that was just doable, from the perspective of watching the lectures. Then I started to do the homeworks, and next thing you know, I'm having to read through lecture 4 just to do one of the questions. But that's up to me. That's kind of up to the individual to go forward in the homeworks. So I feel like it's just about right. Say I probably spent two hours, I guess that's the total time watching the lectures. Then another hour or 2 maybe teasing through the homeworks. So 2 to 4 hours feels about right. If we went to double to 2 weeks worth, 1, 2, 3, and 4, I think I'd have to start throwing my hands up.
Yeah.
Based on this week, personally.
Yeah,
Well,
I agree with Dave. Like, I was able to finish the videos, even though like I'm working and I had other commitments. But yeah, and then when I started working on the questions, then I got stuck. So I haven't finished them yet. But I think it will take more time to finish the question part.
Yeah. And that's kind of the nice part about it. If you feel ambitious one week, you can kind of keep charging through the homeworks, which will lead you into the next lectures. If you don't have the time that week, then you don't. You just listen to the lectures. And so we have to be careful about knowing that some people might be a little bit ahead, that we have at least a minimum expectation each week. So, yeah. It's like everything else, you can dive in as deep as you want, but we don't want to leave people behind, except it is going to be it's like half a year, right? Something like that.
Well, it's 10 weeks long, so it's
10 weeks.
Yeah, so that's 2 lectures a week.
Oh, that's not bad. That's not
So
bad.
it's about 2.5 months. But if we do 1 lecture a week, then it takes like 5 months, which
1 a week, right?
Too long.
Oh, that's right. We were deciding whether it was 1 lecture or 2. Oh, I see. I'd be okay if even 2 was too much for the group. I'd be okay to back off a bit.
Yeah, that's what I would say. I'm
I see.
empathetic to folks who are working.
I work too, but I work from home, and it's kind of easy to get up in the morning and watch a lecture. Personally, I'm an empty nester, no kids, so I have more time than most. We should, I guess, vote on it at some point.
Yeah, but I'm definitely down for 2 a week. That would be my vote. But like I said, I'm empathetic to those who wanted to lower it. I wouldn't be against that either. But I do prefer 2 per week.
One suggestion I could give is we can go 2 per week, but then I think let's also have some kind of a slack week, wherein so that people can catch up, because it's not like you'll be able to go on the same momentum. So it'll be good. Like, for example, after 3 and 4, can we do 1? and then 2-2-1, something of that sort, so that somewhere in between, we don't have to finish in 10 weeks or we don't have to extend it to 5 months, but somewhere in between.
That's a good idea.
Yep.
Yeah.
Just work that into the schedule. That's really a good idea.
Yeah, I guess we can maybe
Do they logically group in any way that would lend itself to having a week that's a little bit slower? Low.
if the
So I think one thing I'm seeing is that, let's say, for example, we can do 3 and 4 next week, but label propagation for node classification can be just 1, so that we can just give time so that people, if let's say even me, if I'm also working full time, so if we'll have to finish it off, let's say, and then and then it just 6 and 7 is GNNs, and then there's application of GNN and theory of GNN, and then you have probably we can do every 5 lectures every 3 weeks.
That sounds great.
Yeah, I like it.
Yeah, let's try that. And Collab Zero, have people managed to give it a try?
I did reach out to the course folks to see if I can get the updated handouts and homeworks and whatnot. I didn't hear back from them, but I assume we're just using the 2019 readings.
Yeah, kind of. I think that's the best week.
What's a reading? What does that mean, a reading?
They have you read chapter 1 of the graph book and read this periodical on such and such thing.
Yeah, so they actually have
I don't have those books.
Well, everything is accessible online for free. But then, for example, there's some things that you have access to the database from a library, for example, maybe if you're affiliated to a university or a local library.
Right. And does this schedule merge with the current, the 2021 one fairly well?
It's a bit of a little bit mixed. So some of their stuff is the same, and then they kind of there are some that's shifted around. And then I think, and my impression is that this year they kind of have a lot more stuff on graph neural nets or more detailed version of it.
Right.
But I think
that's there. I mean, these are more of an analysis on networks. I think the shift is more into GNNs this year.
Okay, well, maybe somebody could look ahead and try to map the readings into the current week content, which doesn't look like it would be too hard to do. But
I don't think it exactly maps, because one thing that they've given is for the schedule that Wendy had shared, I think they're given graph representation learning book, which is available. But then, yes, I think I'm learning graphs too for the first time. So if anyone else was a little bit more familiar, would be great to answer that.
well, yeah, it wouldn't take much probably to look at those topics and then say, oh, this one is not covered at all. At least we should know that. Maybe skip this one. This one would be an optional reading. But then maybe in week 6 of the old schedule is a topic that's covered in week 3 of the new schedule. Be nice to know that. So that won't be hard. We'll try to do that in the spreadsheet if it's available for editing or not.
Yeah, you should be able to edit it.
Okay.
If it's still not, then let me know.
The more ambitious of us maybe can work on a column or 2 that has what we think is the relevant readings. I didn't even see those readings. Yeah, we'll see. I tend to dig into homeworks just to kind of sort out what's important, at least from the instructor's perspective. And that usually takes me a long time just to tease through some of those questions.
Yeah, I think the homeworks, the easier ones are actually the ones that you try to do in code. There are a few questions that are like derivations and stuff like that that I just didn't really manage to do before. Because I went through the 2019 stuff kind of in 2019, and I just gave up some of the homework because I got stuck. But maybe this year I'll manage to do it.
Well, we'll see. I haven't dug into the homework. I've only done the collabs, and I'm just in the middle of the first one. This second one, actually.
The 0 and the first one, right? The collab 0 and 1.
Oh, I don't know. What is it? Collab 1?
No, you're talking about the collab notebooks, right? There was one 0 and there is a 1 in which I think you had asked about this question
Right.
4 on the forum.
Yeah.
I'm just
Collab
going through
1.
that only right now.
Yeah. It's, it seems basic, and you just have to kind of search in the lecture a little bit for what he's talking about, and then do some looking into the Network X documentation just to get a good feel for what is the question. And then the coding is, you can figure that out usually. I think it's just practice. I think the collab, those are just kind of practice, and then I'm sure the homework is a real problem, right?
Yeah, that's my impression. The collabs are more like practicals.
Yeah, little warm-ups, little tooling. Yeah, so I think this feels about right, and the material is new to me, and that's very current. I was just driving. Yeah. I was driving very fast to get back here by 1 o'clock Eastern, and I was using Google Maps, and I was thinking about, oh my God, he mentioned that Google Maps was graph based, right?
Yeah, it's a new thing.
Right.
I think this year, the work done by DeepMind actually using graph neural nets to Google Maps.
All the segments, and I'm thinking, what are the attributes of the segments? It's distance, it's travel time based on the traffic. So it was putting all those together, trying to get me home faster. And I noticed that oftentimes it doesn't even give a full time. It just says similar ETA. So I can tell it's kind of have some probability, of course, built into that. And as you change your location, the entire way home changes. All the potential ways home. So that's pretty fascinating.
I wonder what the tie-in with what we're doing here is with that causality class that's been promoted quite a bit on TWIML.
Yeah, he's pushing that pretty hard, it seems. Has for about the last when it first came out, what, 5-6 months ago?
Yeah, I'm in it. I'm actually in it.
So I put a link to the TWIML, Alex Smola, I guess, from AWS, is like 3 weeks ago. He did his TWIML interview. He does talk about a lot about causality, and he's deep into graphs. So there must be some pretty good tie in.
I'm in the court. I was in that first cohort, but I just didn't have the time to dedicate it to it. So I never participated, but I still have access to the lectures that I paid for. And so, but as I began it though, there seemed to be a huge tie-in between the two. I don't know, but I think I'm going to just start taking that course simultaneously because I think
I can only bite off so much. I usually have like my bread and butter stuff that I do, and then I'll choose one new and interesting thing, and this is my new and interesting thing. Causality did seem super interesting, and I think he mentioned stuff like trying to prove causality by predicting one or the other based on connections from one to the other. And if you can make predictions, then there must be a connection. Then there must be a cause. There must be a causal link. If you can use the link for predicting, then it must be causal. That's pretty fascinating, just that statement.
Yeah, I'm definitely gonna do it. I'm pretty much, this is all I'm doing for the next couple of months is just studying, so I have the time.
Oh, cool. Great.
I'm
Yeah.
trying to, I just got accepted into a computer science artificial intelligence master's program, and so I'm trying to prepare myself
Ramping up. Yeah.
for that program, which starts in August 21.
Yeah, then you're the people in the course having to do the homeworks, and
Then
more than one course at a time.
exactly.
Yeah. Yeah, this is probably good practice for that.
I think on the causality course, I actually tried that as well, like a few months back when it first started. And I think I don't find it very easy to understand. And kind of, I just don't kind of get the intuition. But what I found was actually there's a course that's course plus book called Statistical Rethinking. And that actually, it's a slightly different bent to the course from on the TWIML thing, but it kind of gives you more intuition around the basics of Bayesian data analysis, and kind of and also kind of like a bit on the causal modeling as well, as you kind of get later like a bit more into the course. So just
Is
handy.
that a Stanford course? Did you say statistical reasoning?
No, Statistical Rethinking is Richard. I can share it in Slack later.
Okay.
It's not from Stanford, but he's very well known as well.
It's pretty common for most causal models to be Bayesian inference type stuff.
I got it here. Yeah. Okay, I'm gonna check that out.
It's also really useful to know because a lot of the people who work on like general artificial intelligence use not only like neural networks and pattern matching type things, but they'll use Bayesian inference, building causal models, and then also link it with symbolic AI. There's some interesting courses on through MIT that you could probably watch to cover that. But it's an interesting topic. Like, how could you predict what an agent will do? Because you don't want, it's common in robotics and stuff as well. Because as opposed to this, where you're just like, what's the fastest route home? All right, that's fun. But if you want to have like true artificial intelligence, you have to go in a completely different direction. So it's good to know. If you plan on studying artificial intelligence and not just machine learning, it's something checking out or digging through.
Yeah.
Well, yeah, for me personally, you know, so I asked the director of the program, look, how can I prepare myself, given my background? And this is one of the areas that he had mentioned.
How are your stats in linear algebra and multiple?
Calculus, linear algebra, fine. And there's a a great kind of a brush up course I'm taking called LAFF, LAFF.
On EDX.
Yes.
Yeah.
Out of Austin. But on the stats side, I just always been really weak there. So I'm like, kind of a little nervous. I'm like, damn, I got to really catch up. I don't have very much time to do so.
Yeah, I would really try to get through basic linear modeling, make sure you have basic stats, and then do a probability. There's a course through Harvard that's online, like kind of like this, where it's not for paid. Stats 110. So if you just Google Harvard Stats 110, there's a whole course of probability. He has the homework, he has the tests, and he has like study guides.
Oh, cool. Okay. Yeah, I've just a 110. All right. So would you think that doing this Harvard course versus reading the Richards book, Statistical Rethinking, would be a better approach?
The statistical rethinking sounds like it might be a challenge if you're not very familiar with probability, combinatorics, random variables, PDFs, those type of things.
Okay. All right. Okay, cool. I'll do that then. I've got it here. It's just, it's 110 probability. Yeah, I feel weak there. So thank you.
No, no problem. So I think in terms of graphs, this, from my perspective, it was a relatively easy week. There wasn't anything too challenging. I was looking at Colab 1 and kind of working through it, and it's one of those type of things where it's pretty common in classes where before they let you start using libraries, they want to make you implement it directly. So you're doing like the different metrics in between, like how to calculate like centrality and things like that. So it's a little, it's kind of just, yeah, tedious, but it's not too challenging.
I find those to be actually the single best way to learn is to just have to think about it really hard.
Yeah.
Something, and it might just be like just the one time I had to think about PageRank and actually, you know, write the little thing that it does automatically. Iterate one, you know, that was the question, iterate once. Where normally it's going to iterate the whole thing and comes up with a number that's, of course, a little higher than the first iteration. But just doing it, you thought, oh, now I got a really good feel for what that means to have neighbors that are also important. That would make you important, you know, that kind of thing.
Yeah.
Yeah.
It's useful. It's just going to get like,
you'll never use it again. You'll never do that again. But the fact
you
that
start working on a library or something, I guess.
Yeah. Yep. Exactly. It's like just your basic tooling, and it's kind of mental tooling at this point.
Yeah, and also it's a bit like you kind of, if you once you've tried implementing something from scratch, you're really stuck in your head how it works.
Yeah.
Kind of, I think I tried some stuff around like kind of like there are some basic reinforcement learning algorithms that you can just call on using a library, but I kind of tried out a few implementations on my own, and kind of after hours of debugging that stupid stuff, I think I more or less understand how it works now.
Yeah, I think we all have stories of spending hours trying to get a matrix to not throw out, you know, whatever a matrix. Andrew Ng's course, there's always a time when you cannot get the matrix to work out, the matrix size. So you just have to mess with the shape or something.
Yeah.
You do get an appreciation just spending that time and energy and focus. It might just be mostly focus. We spend so little time focusing anymore that this forces you to focus on something.
One of the things that I always found interesting, kind of challenging, is like I can symbolically do the math like on paper, but then trying to figure out how to turn that into code, like doing custom coding, like backwards propagation and stuff like that. It's like, it's the math you can do relatively easy, but then turning that into the code where it has to take every step and you have to handle the variables, and it's a lot more challenging.
It's a different skill set, or it's a different discipline. It's not a different skill set as much as it is an approach. So I'm in another study group that we started that we all were working on one of the TWIML, I forget exactly what, but we kept on Fast AI. And there's one guy in my group that can just go through the code and make it look just like a book. And it's a very powerful skill that I sit here and watch and try to mimic sometimes. Because he did, you know, he'll rip through the backwards propagation, the breakout of the layers. And he just says it helps him think. And it's hard for me, just like it is, you said, for you, Andrew. I can hardly get those projects done at all.
Get done, but might not be pretty.
Yeah, right. And a lot of copy paste, you know, where he likes to do it from scratch. He goes, you know, you don't learn anything until you actually write one of those routines from scratch. Because you have to think through every aspect, every parameter that's in each of those calls, the defaults. And then you kind of get an appreciation for the way in Fast AI, for example, has a lot of tooling that just kind of comes with the library. And I assume Network X same way. I'm teasing apart Network X a little bit. It's like, wow, there's a lot of functionality in there.
Yeah. What, so a question, just because I'm looking at what's being shared on the screen. These readings are from previous years, correct? And there's no readings for the current course.
Yeah,
I
so
just
this,
think they're listed for the current course yet.
Okay. It is possible that the way that the professor decided to rework the course, he didn't want to have assigned readings. Because I've been a teaching fellow, and I know kind of like we've dropped tons of reading that was either after student feedback, it's just too much for them, or like the course just shifted in a different direction. So I don't know if it's necessarily going to match up really well.
Yeah, that's kind of what I thought when I looked at them. I thought maybe some of them will, and if anyone can figure out which ones do relate to the Givens weekly things, it would be nice to know that ahead of time.
So coming back to the question of homework, since this homework doesn't align with what we're doing, what are we going to do about it?
well, I think the idea is still to try the 2019 homeworks. I mean, I think it's still useful, kind of. I think, as I said in Slack, it was kind of like 2 years ago now when I tried it, but I think there's still a lot of relevant stuff in there. And given that we don't have the homeworks for this year, it will still be a useful practice. But again, it's kind of like everything in the study group is optional. So just do as much or little as you want, really.
Yeah, and I think they will not give the homework out because I think these are pretty recent, right? Like it started in on April 15th. So I think the homeworks will be available one day after the course is done.
I'm not so sure. I think because where is it? Yeah, is it here? Yeah, because like so the course is actually in Jan. They finish in March, and they still haven't put it out yet. And like in 2019, you basically get the homework link as soon as the students get it. So I'm less sure that they're actually going to release it this year to like the public.
Cool.
Developing homework takes a long time. So a lot of the times I've seen this more, even with the online courses, like courses that you can see the content material, they won't give it out just because to redesign custom homework every year is a big pain. So it's better just to like keep it kind of hidden and then hope that the students don't share it amongst themselves in the between years. But when you throw it online, it becomes a whole different type of headache.
Yeah.
People will start writing like Medium articles on it and everything. It's just like, no.
And also, it's also usually like the homework stuff, like quite a few courses that please share solutions on GitHub. And obviously, if you let the public have it, like no one's going to listen to you, and you can't really punish them either.
Yeah.
Because they're not your students.
Yeah.
So the homework, I haven't opened it and looked at it. Is it truly on different topics?
I was looking at homework 1. It's the bundles are like PDFs, and a lot of it's not like coding exercises. That looks like.
Well,
there's like questions on clustering coefficients, degree distribution, recursive features. I mean, it seems to match up okay, but we've only done the first week really. So
those are just like research and find an answer and then kind of just write it down. There's no actual development.
Well, there are some like some Python stuff that comes with it, but there's like a submission form where it's supposed to be, it's like written or something. I don't know.
Okay. Well, we'll get into that.
I think each week would have at least one question that you need to code, but it's not all code.
yeah, I just hope it touches on the material that we're actually, going through on the handouts.
Hey, Wendy, would it be helpful if we can like say that this week we are supposed to cover these two lectures, let's say lectures 3.x and 4.x, and collab 1 or collab 0, whatever it is, and this is the homework. Like, if we can have this kind of an information, then it'll be central, it'll be like helpful. Else, even I had a doubt whether.
I agree.
And also, if we are to do some kind of a staggered schedule with, I think not week 5, every 5th lecture being a kind of, for only 1 per week. I think right now it's 11 weeks and it will extend to 15 weeks. Do we need to do a poll on it, or what is the general idea about it?
I didn't specifically get the question.
No, so the thing is this, like we were talking about the schedule, right? So schedule right now is we finish it in 11 weeks. So if you're going to do like every 5th lecture is going to be like basically like a staggered schedule, right?
Right.
We do first 2 weeks now, first 2, like 1.x and 2.x. This week, 3.x and 4.x. Next week, and the next week only 5.x, right? So that people can catch up. So are we on? We're going to do that, or how are we going to create the schedule?
I think we decided to do that.
3-4.
So yeah, next week is 3-4, and then we would have 5 the following week, only 5.
Okay.
And that will be the week that we kind of do catch our breath, maybe review our process.
Yeah.
I would think maybe next week we should maybe attempt to have all of Collab 1 and maybe read homework 0 as a minimum.
So about that homework thing, when you say read the homework, we're talking about reading the homework 0 from fall 2019, right?
Yes. That's
Okay.
that's the only homework 0 we have.
Okay, because that one, to me, it doesn't seem to be like really a reading one. I mean, it's all the 3 questions are all are requiring you to use various tools to analyze the data. So I wasn't even sure I was looking at the same thing as you guys are.
Really?
Yeah,
that-
homework 0 is all about practicing with network, like calculating stuff in code. And you can, I think, so I use network X instead of like snap.py. But I mean, kind of, I think in previous years, they kind of make you go through snap.py stuff. But my impression is that this year they're just going with network X and towards geometric. So I didn't really bother with.
I see. So homework 1 has a lot of snap.py.
That's homework 0.
I'm sorry.
So this year, like in the new schedule, they don't have a 0, but I think because like 0 is probably like just getting used to the libraries and stuff. So that's probably why they might have just excluded it, given that they have
Got it.
more.
Got it. Well, we just have to just kind of, somebody has to read ahead a little bit and make a decision, or at least inform the group like they're doing now. I have no opinion because I haven't read it. I have not read homework 0. But do you think we should at least be prepared to go over Collab 1 next week? Or is that?
I think the initial idea was that next week is I mean there, because like there's a schedule thing.
Yeah, I'm looking at it. Yeah.
Yeah, I think the initial idea is that it's homework 0 next week,
Got
and
it,
then
got it,
collab
okay.
1 after that.
That sounds okay.
Yep, that sounds good.
Okay.
I'm gonna have a lot of tool learning. Homework
Yes.
0.
Me
so.
too. Well, and I'll debate myself if I think that I don't want to learn snap.py because I just won't do it.
I think I'm gonna do network X as well. Same as Wendy. That's what you're doing, right, Wendy?
Yeah, so I haven't finished it yet, but I managed to do most of homework 0 just using network X.
Okay.
Oh, okay. Homework 0 refers to the 2019 version, right? Not the collab one, what we're talking about.
That's right.
Okay.
Yeah, we might as well get let's get our terminology straight. Anytime we mention homework, any homework, it's going to relate to the 2019 material.
Right.
And the collabs, I think, are the same, aren't they?
Yeah,
Well,
collapse.
Except,
Okay,
you know, collabs,
we have access to
collabs,
2020.
homework is homework. I mean, labeling wise in the course, they're different. So
We're just looking for which material to go off on our own, try to solve, in addition to the watching the lectures.
yeah.
And this is good material, I think. So is it possible, like Wendy, like you said, to implement what is asked in homework 0, but do it in network X, even though they might request that it be done in Snap?
Yeah, so I tried using Snap before in the other homework, but I don't recall any real selling points of it from network X. I think because it has a C port, it might be a bit faster in bigger graphs, but again, like tooling has moved on, and like if you have a bigger graph these days, you can probably use something like QGraph rather than Snap.qr.
So on the network X, and I mentioned this last time, I'm reading a book called Complex Network Analysis in Python. That might be, for me, it's going to be a nice additional thing. Cool.
Yep.
I know someone here has already read it and they thought it was pretty good. Was that you, Dave?
No.
Yeah, last week someone had mentioned. I remember.
What tool do they use?
For homework 0?
No, well, in that book, do they mention?
Oh yeah, it's network X.
Okay.
Totally. I mean, like I'm looking at it right now, and first it talks about surveying the tools of the craft in chapter 2. It talks about iGraph and network X and other things, but then it goes, chapter 3 is the introduction to network X.
Yeah, that tells me that it's pretty much front and center of the tool, at least for learning. Certainly production implementations might have a whole different thing, but that I'm not there.
Yeah.
So I'll be biased towards probably learning network X, and I think I could use it at work for some other stuff as well. So I have an agenda for network X.
Yeah, cool. You can get that book at Pragmatic Programmers.
Okay, that's a good one. That's right. That was somebody mentioned Pragmatic.
That's me. I mentioned it.
Okay. Okay, so next week, homework 0, in any way that we can, any way we choose to dive into that, we should at least have tried and be ready to discuss this coming week, along with lectures 3 and 4.
All right.
Does that sound right?
Yep.
That sounds good. I like it.
Yeah,
Cool.
excellent. This is always fun. I love these things. And thanks in a weird way to a pandemic. We're doing more of these. Yeah. All right.
Cool. Well, thanks for coming. Have a good weekend.
Yeah, I was going to ask, does anybody know what that absolute value of G what is that thing?
Is that the count of number of nodes?
Is it?
I
No,
mean, that's my intuitive guess, but I'm probably completely wrong.
Well, it mentions in the same formula, it mentions n, lowercase n, which is the number of nodes. And
Oh, right.
so this is just normalizing n over absolute value of G minus 1. What is that absolute value of G? And it's right there in the network X documentation. Okay, well, I'll figure it out. I'll keep researching. It's not in Google.
This was not in the slides, right? we're not talking.
Exactly. So the question in the collab is figure out how to do the centrality, but you can use network X, but be aware they use a normalization factor.
Yeah.
And in the documentation, it shows you what the factor is. And it includes this term I've never seen before.
I remember seeing it though in the lecture.
And I did a Control F on all the PDFs for that symbol, line G line, nowhere.
I saw it in the lecture. I know it because when you just mentioned that, I'm like, but I don't see it in the slides now. I'm looking at the
I
slides.
think someone mentioned in Slack in the
I didn't look.
Neo4j, documentation it is mentioned the normalized closeness centrality is equal to number of nodes minus 1 by divided by sum of distance from node to all other nodes, something like that.
Oh, a distance thing. Okay.
So one thing I did was the link you posted, right? There is a source button there. And if you click on the source, what the value for that is, it's just length of the graph. They call LEN on graph. I'm not sure. I assume that it would be number of nodes, but yeah, you can see the source code as well.
Perfect. What a solution. That's what the smart people do. Look at the source. Thanks so much for that. I'll look into it and post an answer at some point. Thank you. Have a great week.
Yeah,
Okay.
thanks.
Thanks,
Bye.
everyone.
Okay,
Bye.
bye.